We are going to continue our PyTorch TensorBoard tutorial. We messed around with it yesterday, and also I would very much like to see if we can use what we've learned with the CNN and re-implement a CNN. I think we can do it. How do you track the loss with TensorBoard? We're going to find out today, aren't we? We're going to find out. Torva, hey, there's TensorBoard. All right, now we finally got to it. You know, it took us a little while there. Where is it? It's right here. Okay, so we can copy and paste this, I believe, and see where we're at. Okay, there we go. Perfect. Thank you for those party poppers there. Good to have you here. Okay, so I want to pin this. This is our TensorBoard. We saw we got all of our animals. Well, I want it all open. It doesn't have to like hide them. I want them all open so you can see all the animals. Hi, Mark Lemon. Good to see you. Welcome on in. Thanks for clicking the hello button. Okay, so we've got our TensorBoard here. Everything's all nice and tidy. What I'd like to do is continue on with the TensorBoard tutorial. And then if we have time, I'd like to do a CNN and figure out which is what, right? We can do some classification. Let's get this party started. Yeah, you made it on time right at the beginning. Good to have you here. All right. Thank you for the hearts, you guys. Appreciate it. Okay, so let's go back over to this window here. And I believe, yes, we got to rerun that. That's the rerun command. Okay. Double flush. We only need one flush, right? Let's try it again. Double flush. Okay. Above, we used Torch, Vision, and Matplotlib. We did a little bit of Matplotlib. There's no point for Matplotlib, though, if you're using TensorBoard, to create a visual grid of mini batch of our input data, which is a picture of... We changed it to animals. They have this clothing. We changed it to animals. So below we use add image and writer summary, and then we flushed. One thing that they did not mention that we figured out eventually is that this string right here is mandatory unique. So if you want to add more than one image to your TensorBoard, you have to change the title. Otherwise it overwrites it and you get something completely different. All right. Okay. I want to graphing scalars to visualize the training data. Okay. So this is where I believe we're going to start seeing some of that. What were you asking about earlier? How do you track the loss with TensorBoard? Soki, that's what we're going to do today. We're going to do that today. Okay, so let's define a model and categorize our image tiles and optimizer and loss function training. So we need to write this out now. We need to write this part out. Okay. So let's go ahead and do this. Where are we here? So we've got all of our data imported. We don't really need Matplotlib anymore. I'm just gonna delete this because it's just a little bit much. We don't need it anymore. Okay, get rid of that. All right, we've got our data writer extractor. So this is TensorBoard stuff. And we've got our classes. And we need to create our own component. Now, because we're doing something a little bit different, we need to change how we're doing this because we need to normalize it. We need a normalization function. So let's create our neural net. We're gonna call this something over here. All right, then we're gonna bring this in over here. Okay, so let's do class net. This is gonna be a torch.module, I think. Def init. And then we're gonna do self, comma, and we're gonna want some other things in here maybe. I'm just gonna do self for now. And we do super self, comma, net. Is that right? Did I do that correct? Oh, .init, which is really annoying. Oh yeah, okay. We did that backwards though, apparently. Is that really the reason? Oh, so right now we've got ourselves a TensorBoard here. We got ourselves some training data, a scary dog. We got dogs and cats, and we're going to be normalizing the images, and we're going to run them through CompNet, and we're gonna be training the CompNet. We're also going to be printing the output of the loss to TensorBoard. We're just gonna try it out. I've never done this. I've never used TensorBoard before, except for yesterday. Steven we are watching him because to become one. Yes, exactly. We're going to become a PyTorch expert. Let's see, is this like a demo? Yes, you can consider it like a demo. Exactly. Noted, yes, exactly. We're doing the PyTorch tutorial. Integrating the features we want that are interesting to us. You got it, Torva. You got it. Okay, so let me go back over here. We need to convnet. We're gonna have a couple convnets here. Oh, right. I remember this. And then we have to do some views. We have to change the view so that way when we go into our linear layers, it changes it up. Okay. And there's no activation. That's weird. Oh no, there's ReLU right here. Okay, we got some ReLU. We can be fine with that. That's totally fine. Okay. So self.c2, basically same thing here, except for it's going to be a 5. No, this will be a 6 because we got a 6 here. And 16, maybe? All right, well, we can do 16, that's fine. 6. Why 4x4? Maybe it's the color channels. Oh, we're gonna do all the colors. No color left behind. Is that really the case? 16 4x4 or 120? Okay. We'll do self.l1 equals torch.nn linear. And that is going to be, you said 6 times 4 times 4. We can do 120. 2. This will be 120. Let's do 120 by 120. And then the third, and the output classes, I believe, it's cat or dog, right? So it's going to only have 2 classes. So we're going to modify this. So it's going to be 120, and the output is 2, like that. Okay. Looks good to me. And then we're also going to have a pool, and that will be torch.nn.max pool 2D? 2x2? Is that right? Is that what we're gonna do? Some here. Let's see here. All right, so self out, that is gonna be, we'll do right here, f.ReLU. And we need to do that. Oh, we need to run a pool over this, okay. Self.pool, like this, all right. We have to put the activation in between there, so that way we normalize on a nonlinear level. Then we take the pool, which is gonna give us the maximum value of all the corners. And our corners in the pool, I do believe, are gonna be 2x2. So within 4 values that we're scanning over our grid, we're gonna get max values from those. So we do the same thing with conv2. And then we're gonna change the view. Out equals out.view. -1 comma. And we need to see what the length is. Oh, we don't. We already have the answer. 16 4 4. This is gonna be the color channels. We might have to change it because we might have different color channels. So this is flattening. This is a flattening. Flatten the 2D matrix to 1D vectors, right? So that's what we want to do here. Copy paste these. This is going to be a linear out on the final output. 3. This will be 2. Okay, I think we've recreated, for the most part, the tutorial. The only thing is now our input data is not going to be a 32 by 32 picture. We need to change our norms. And so this needs to be different. I think we need to resize. I wonder if there's a transform resize. Do you guys think there was one? Moons, thank you for clicking the hi button again. How many can you click? Are we gonna get a new record? I'm kind of curious about that. Okay. We need help here. Okay, so what I'm gonna do is I'm gonna close this. This is an empty directory. All right, Jiminy. Transform 2D image and say like various sizes into, what do you call this? Like a uniform, into uniform, let's say like 100 by 100. See if we can do that. World provider, you're welcome. Good to have you here. No. All right, so it's here. Resize. Oh, it's called Resize. Oh, how easy is that? All right, perfect. Here we go. Boom. Resize. Easy. All right. Make that super simple. And this will normalize the color to center, which is fine. It's not going to matter that much. What we could do is we could change that up, but we're not going to. We could find the center. We could find the center, but we're not going to. We're going to just leave it at 5. Okay. All right. Okay. Here we go. So now we've got our transform. Is this going to work? Oh, yes, it will. That's why the images look so weird in our TensorBoard, because we were normalizing to 50%. Let's do something a little bit different, shall we? Let's comment these guys out really quick. And let's rerun this. Compose. PyTorch module. Maybe it's .nn. Like that. We gotta do that way. There we go. We fixed it. Yeah, we fixed it. All right, we fixed it. Okay. Good to get. So let's take a look at our. Oh, where's our kitties? Oh, good. Okay. Hey, now they look good. See, I told you. So we did some normalization on the pictures to make them difficult for a human to see what they look like. But now we've got pictures that are a lot easier to see. You can see what's going on there, yeah? Because we normalized them before. Every animal on the planet. All right. Okay. What else we got? Dog. We're dog heavy today. Lots of dogs. Oh, there's a cat. Okay, so this is our training data. So let's do a resize on that. Let's do a resize. All right, let's see what that looks like. So now it'll be all squashed into the same 100 by 100. 0, 0, 0, reload. That didn't resize them. Didn't it? No, they look the same size. Hold on. Let's try it again. Where did you get these images? They are so cute. Are they loons? Well, I got your answer. Wait there, it's called Oxford IIIT Pet. Oxford IIIT Pet. It's a dataset that comes with Torch Vision datasets. Right there. They make it easy. So that they're like datasets that allow you to do these types of tutorials really easily, so you can create your own models over that dataset and get really good results. All right, so we should see a normal. Why isn't it normalizing it, you guys? What's going on here? Well, I should see a resized 100 by 100 pixels. It's not doing that. Why isn't it not doing that? It should be. What's going on, you guys? All right. Let's see here. Okay. Because I'm having it run through the transforms. See here. Checkpoint time. Lions for lamb. We should probably do this. I think the tensor out here at the top is what we want. We want to convert it to a tensor as fast as possible. We're going to resize it. And then I want to normalize it. Okay. So now all of our images should appear sort of dark looking. They should look a little bit darker. It worked. It worked, you guys. It worked. I don't know why. I have no idea. Why did it work all of a sudden? It worked now. Apparently the magic breakpoint did all the things we needed it to do. Not really, but it did. Look, they're all square. They're all square now. We can run it through our CNN without it crashing. We've got uniform batches now. This is great. Hey, we did it, you guys. All right, now I'm excited. We'll restart TensorBoard. TensorBoard. There we go. Reload. Yep, there we go. See, now it's a higher resolution. This is 200 by 200. We doubled the resolution on the input size. Okay. So let's go ahead and renormalize that. Rerun it. Start TensorBoard again. Reload it. There we go. See? We figured it all out. Using TensorBoard, and we're learning how all these things work together. The internet changed everything around that time. It sure did. The whole world. September 4th, 1998. That's when it all changed. True blue. That the .com. We're getting close to the .com bubble. You're an insult filter. An insult filter. Oh, yes, I am. Loons, you can tell. Yeah. Uh-huh. Grace Hopper changed the game creating COBOL. Yeah. Thank you, Grace Hopper. Hello, Steven. I hope you're having a good day. We are. Thank you so much for saying, Anshuman. Good to have you here. Welcome on in. So we're currently using TensorBoard, and we are creating a CNN, and we're going to be training some images, and we're going to print the loss rate in a graph on TensorBoard. You know, all this juggling of TensorBoard to have to refresh everything is a little bit more effort than I think maybe it's worth. However, I think we're gonna be fine. There we go. Okay. So our classes are not these. We're gonna have different classes. We're gonna have a cat and we're gonna have a dog. Also, I need to print out this training data really quick because I need to see what's going on with it. I need to see how things are labeled. So we need to capture some of this data here. Let's go image grid labels. Let's do labels. Say plus, you know what? A better idea. Cat or dog, and it's going to be a label. There we go. Image. Oh, grid. Let's just. We need the label. Oh, you know what? I've got a better idea. For image in images, add an image. We're gonna say cat or dog, and we say label equals. We should enumerate this, right? Is index first? Do you guys remember? Index is first. Label equals labels index. There we go. And then we've got our image. So I think we can do image label like that. You think that'll work? Let's rerun this. Okay. Oh, it's weird. Very odd. What is that? What's going on? Oh. So we're gonna have a lot of classes is what that means. Not just one or two, but many. There's many classes. We're gonna have to figure that. We might not be able to, I wanna train this model. Looks like the max is gonna be like 34. You see anything higher than 34? Let's do this programmatically. Label 0. Okay. And we're just gonna say label 0, label num. Label, so if num, no, if label is, if the number, okay, yeah, let me reverse this so it's easier to read. So if the label is larger than our current number, we're gonna set the number equal to the label, and then we're going to we gotta print it out. Print num, there we go. All right, we're just gonna do a little exploration here, just a smidge of exploration. 36, okay. The answer appears to be 36. So there are 36 classes. Let's try it again just to double check. We'll go for 30,000. There we go. You click a lot of buttons, gotta click all, yep, you sure do. You think the F2P XP caps out at 150. Oh, does it, Bonzupi? Let's see where we're at. Yeah, so the answer is 36. Okay, so that's the number of classes we've got. I can delete that code now. I'll leave that here. Okay. La 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 la. Looks good. Looks good. Okay. And we need to make our classes. So our classes are going to be a range, and we'll list the range. It'll be 36. Okay, so that's our output size. So I need classes. Classes equals 10, but we need to default that. So model. We've never defined it yet. Let's define it. Net, and it's going to be 36. Let's see, number of classes equals 36. So we know what's going on. There we go. Okay, so that's the first input. And then we need to take that input and put it over here. Classes. Like that. So that way, it's going to be able to correctly calculate which breed of animal it is. Because we got 36 options. I don't know what their actual labels are, but I know what their numbers are. I know what their numbers are. And because we should one-hot them, because we do get better results when we one-hot them. However, for now, I'm not going to bother with it. Because this is default, right? Stride. Strides 2. Our window for our max pool is going to be 2 by 2, right? So we're going to go. So we max pooled this, and it gave us some extra data. All right, so let's go a step further. Let's go to view. Although, wait. Oh, it worked. Okay, so now we need to convert to the linear layer. So let's make sure that it's all a vector. Okay, so it's not enough. We need more. We might need to, that's a very big, that's very big. Shape -1 800 is invalid for input size of very large. We need to change that. We need to change it a little bit. Should we repool it? Do we want to pool again? It's very, very big. How about this? We just increase the pool size, the window. So make that a little bit smaller. Yep, that dropped it quite a bit. That dropped it a lot. Nice. Let's do a 4x4. So we drop it even further. Okay. And then, oh, hey, I like that now. But you know what? I don't know if that's big enough. I don't think that's big enough, you guys. Let's see here. I think we got a problem though. It definitely gave it the right shape, but now it's like too. Sorry for my spelling. You probably want another layer so you're not losing info on a linear layer, like doing a conv rel into a conv rel. Yeah, we are. I think. Let me double check here. So look at that. Does that make sense? So we're doing 2. So we're conv layer rel u. And we don't pool. Oh, so 1 pool. Like that. So we'd only pool once. It's pretty much linear behavior. Yeah, a pool is definitely linear behavior. I'm doing 2 pools. Yep, basically. Okay. All right. Here. Maybe do that twice? What do you mean? If you want 2 pools, do a 4 conv layer. Do 4 conv layers. Really? Per image. And then you're thinking of stacking those. Okay. We're going to have to continue this tomorrow, though, because we're hitting the end of our time window. Though, I want to play around with this just a smidgen more before we head out. Just a little bit more. So, let me see here. All right. And then you're saying we should C2. Pre-pool. See if that works. Does that work? It does? Okay. All right. Magic's happening, and magic is happening. This is great. Function work. Oh, it doesn't. It doesn't really. It just looks weird. Only this one's executed, and then all this code is dead code right now. It's dead code. So this is never used. Never reaches this code. So none of this code ever gets reached, essentially. I'm doing it as quickly as I'm debugging. I'm debugging my forward pass. I want to make sure that this linear layer works. And then we get the full output. I think it will. And there you go. There you go. We did it. The output size seems incorrect, though. Let me double check. Yeah. Let me see. I need to say print out that shape. 200 by 203. That is incorrect, right? All right, so we got a problem here. Our loss isn't going to be able to loss properly. We're not going to be able to get that. We're going to figure that out later. Classes. The classes should only be 10. But it gave us 200. L3. L3 right here. Yeah, it should be right there. Maybe we didn't set that right. Where's our model? Where's the model defined? Model. There we go. Classes right there. Classes 36. So, oh, maybe that is 36, but it says the shape size not. Whatever. See, when E and N, there's a few things that are missing. Get status, get commit -am. Full working, maybe. Let me guys better. Working, maybe. CNN, convolutional neural network. Push that to main branch. Good to go.